Okay, in this video we're going to talk about the addition law. So with this, the events A and B, the addition law will tell us the probability that event A or B or both will occur. That is, it tells us the probability that at least one of two events occur. So, first, let's talk about mutually exclusive events for the addition law. So what does it mean to be mutually exclusive? Basically, when one event happens or when something happens, the other event can't happen. So, for example, it's raining and it's not raining. Those are mutually exclusive events because you can't have both at the same time. It can't be raining and not raining at the same time. Another example would be getting a 1 and a 3 when rolling the die once. You can't roll a 1 and a 3 in the same roll. Like, it's impossible. That cannot happen. Therefore, those are mutually exclusive events. So sometimes you'll even hear in common language that say you have a business and you're selling something and someone says, well, I want something that's cheap, it's not expensive, but also it's a good quality product, but that's just impossible. But you might say, well, those aren't mutually exclusive, meaning that it is possible that you could have a product that's not expensive and still that is good quality. So it's used in everyday language as well. So if you have events that are mutually exclusive, meaning they cannot happen together, right, the equation for it is just the sum of the two events, right? That would tell you their probability. So, for example, let's go back to our example that we used earlier on when we were talking about the complement. Right, what is the probability of giving one head when tossing two fair coins? Right, this is event A, this is event B, right? Or in terms of thinking about getting a heads, right? There you can kind of think about getting a heads and a tail. Those are mutually exclusive, right? So if those are mutually exclusive, they can't happen together. So we could add them together. So let's continue with this, and we're going to do an example. But just know that if you have events that can't happen together, and you want to know what is the probability that at least one of them could happen, right? You can just add them together. So let's look at the addition law for events that are not mutually exclusive, meaning they could happen together. So in our example, right, if we look at the diagram up here, right, event A might be that the product is inexpensive. Event B would be that it is good quality. And then where the two circles overlap would be where these would be the products that are inexpensive and also good quality products, so to speak. So this joint area, oops, sorry about that, is called they're overlapping, or the intersection of those two events. So let's see. So the equation for this, if you have events that are not mutually exclusive, it is the probability of A plus B minus basically the intersection, the probability that A and B happen. So why are we subtracting that? That doesn't seem to make sense. Well, what we're doing is we are taking A, adding it to B, but you notice there's this intersection, right? We have to subtract some of that out because otherwise we're counting it twice. So we're saying A plus B, we have to take out some of this intersection area. So sorry that keeps sliding back and forth. So you might be thinking, well, that doesn't make sense either. Why would we add all these two areas and then we'd subtract out that area? Basically, you'd be subtracting out the A and the B, right? The product is both inexpensive and it's a good quality. Why? I thought that was in the definition that could be a sampling point, right? Because you said in it could be A, B, or both. Why would you subtract that out? Well, we're not subtracting the whole area out. Remember, we've counted this area twice, so we need to subtract some of it out. So here's a 3D image of what I'm saying. So this could be event A. This is event B, right? Some of them overlap. So I've kind of taken this image here and I flipped it on its side, right? What we're doing is we're only, right, because it's overlapping, so there's technically two areas that are overlapping. So we just want to subtract one of them so that we have, right, that intersection area, but we're not counting it twice, because that's in essence what we're doing when we're adding A and B together, right? We already have areas in A that are part of B, right? But when we add A together with B, right, we're counting this area twice. So we got to subtract some of it. We got to subtract some of it. So that's why we're subtracting some of that area, right? Because we are counting it twice, as you can see. So we're not subtracting all of it. We're just subtracting basically what we're double counting. So that's why this is the equation for the addition law for events that are not mutually exclusive. So let's recap at the equations we've just learned. So the addition law that we just talked about, what's the probability that, you know, A or B happens, or both, right? That intersection area, it's just a probability of A plus B minus the intersection, right? But, right, this is for events that are not mutually exclusive. But if we have events that are mutually exclusive, right, what's the probability that A and B happen? It's 0, right, because they're mutually exclusive. They cannot happen together, right, by definition. So if you have events that are mutually exclusive, right, this would just be 0. So then probability of A plus B minus 0 is, right, probability of A plus probability of B, right, which is the addition law for mutually exclusive events. So basically in this slide I'm just showing you, right, why these two equations are different, the addition laws for mutually exclusive events, right. This basically kind of sums it up, why you have these two equations, how they differ, but how they're also related. So I hope that makes sense. If not, message me and we can go through all of this again. Still, if it's not clear, try to watch the video one more time, but again, if it's not clear, we can go through this again. Let's do an example now. So we've talked about it conceptually. Let's say that we have 50 workers and they're being evaluated on work where they get a poor evaluation if the work is late or if it's defective or both. Right, so in this case, we have something that's not mutually exclusive, right? Your work can be both late and defective. So we know we're going to be working with the addition law, right, this equation, right? These events are not mutually exclusive. We're using this equation. So here's the data. 5 people out of 50 finished late. 6 made a defective product, and there were 2 people who were both late and had a defective product. What is a probability, right? That's ultimately what we're interested in, calculating probabilities. So what's a probability that an employee's work is rated as poor on an evaluation? So how can you get rated as poor, right? Being late, defective, or both. So what do we want to do? We want to add all of those probabilities together. The probability of A, right? That would be 5 out of 50. Right, 5 out of 50, plus the probability of B, right, defective product, would be 6 out of 50. But then remember, we got to subtract some of that overlapping area. So what's the probability of both A and B? Right, well, it's 2 out of 50. So if we do that, we get 0.18. So there's about 18% chance that someone's going to get a poor evaluation. So that's just an application of using the addition law specifically for for events that are not mutually exclusive.